Hello guys, welcome to Photons, determination of value of Planck's constant, which is also the proof of Einstein's photoelectric equation. This is Millikan's experiment to do this so. Now, he had a glass tube where he had a window W where he sent radiations of different frequencies such that it landed on the cathode C, which is a metal surface, and which knocked out the photoelectrons until it touched the anode A. And the electrons which touch the anode A, well, they completed the circuit. So that means it sent photoelectric current down, which was measured using the milliampere. Now, here's what he did next. Then, after that, he changed the polarity of the batteries such that, well, there would be a stopping potential. Because this would turn into negative and this would repel the photoelectrons. And well, the stopping potential would be increased to just stop the electrons from touching the anode, thus meaning that, well, the potential energy of an electron would be equal to the kinetic energy of that electron, right? So that means EV naught would be equals to kinetic energy. Now, we know the Einstein photoelectric equation, so let's use that so that we can prove that, which is HF minus HF naught is equals to kinetic energy. Or from here we can write HF minus HF naught is equals to EV naught, where V naught is the stopping potential applied. Now I'll write it here. V naught is equals to, dividing everyone by electron, we have H by E. I'll write it like this. You'll see why. Minus HF naught by E. Now this is a mathematical representation of a graph of a linear slope, which is y is equals to mx plus c, where y is equals to v naught, m is equals to h by e, and I'll write x equals to, well, f, and c is equals to minus, I'll write the minus inside, minus hf naught by e. So what Einstein postulated theoretically was that the graph between frequency and stopping potential would actually be a straight line starting from f naught right here, like this, and here the intercept would be a negative intercept, which would be equal to minus hf naught by e. And of course we can draw, let's say, a triangle here to calculate the slope, PQR. This is theta, and this is the slope, where slope is equals to h by e. And here, what they found practically by practical experiment was that, well, they did find that this was in fact a straight line between frequency and the stopping potential starting from f naught with negative c intercept. It perfectly matched with Einstein's theoretical prediction, thus proving, well, Einstein's photoelectric equation, which was this one. And here we can also calculate the value of h, as here we have m is equals to h by e, but also in this figure, well, the slope is the rise by run, right? So it's pq by qr, which is also the tangent, because the slope is the tangent. So using that e is equals to, well, 1.6 in 10 power minus 19 column, they found the value of h to be this. So they used h by e is equals to pq by qr in this figure, or from their graph, and thus they found the value of h. This is it for photons, and if you learned something new, please like and subscribe. Thank you.